Hello again. Moving on to problem 3 here. Now this is basically the two guys carrying a 22-pound, 15-foot long item, and also carrying a 165-pound block here that is 7 feet back. Now this is of course, my wonderful drawing. This is the great thing. You don't have to be an artist to know what you're doing here. So the thing is, we want to make a free body diagram. Basically, just draw the forces that are being done here. Now, we assume that with the board here, that the weight goes exactly halfway in between. So that's at 22 pounds going down there. And here's your block. Now, admittedly, that's not 7 if the whole thing's 15, but we're going to put it there. And then you have two forces. Force from guy 1 and force from woman 2, let's call it. So you have that. And notice that since this is static, since we're assuming nothing's falling or rising here, your forces up have to equal your forces down. So what we have here, your up forces, which are force 1 plus force 2, have to equal your down force, which is your weight of your item, plus, and this is actually should be 165, it's at 7 feet, 165 pounds going down. Now, adding those together, we can, of course, add F1 and F2 since they're unknowns and we don't know. But we have 187 here. So those two individuals are carrying 187 pounds. So the idea here is that now notice that force person 1 here has to be carrying more if you think about, because this force is closer to them. But again, you have two unknowns here, but you only have one equation. So we need to figure out another equation. Well, if you think about if you're carrying a bar, or even if you're carrying a pen, notice that this thing has a twisting to it. Like I'm holding it here and it's wanting to go down. That's the torque. Just like if you're torquing a wrench, something like this. So if we assume, let's say looking at this point here, we just want to figure out how everything's twisting this. Now again, this is stationary, static. So we have to assume all these twisting motions balance out. So you notice that this is twisting it in this direction. So this force 2, well, remember, when we're talking about torque, it's how much you're pushing up and how far out you're pushing it. Now, this is 15 feet, so your torque there would be your 15 feet times your force. That has to equal all the forces going in the other direction, since they have to balance out and be equal. Now again, we're assuming that this is halfway across here, so that 22 pounds here is actually happening at 7.5 feet going across. This really, really heavy is happening at 7 feet. Now you notice these are pretty close together, so in reality, if you're going to make it a little bit to scale, your second force would be like here, but we're in the right vicinity here. So if we get 22 pounds times 7.5 feet for our arm here is, shock, 165 pounds. And that right there is 165, and then we have to multiply it by 7 pounds, or 1155. Now, just like when we did with the problems up here, sorry about the movement there, we have to combine our like terms on each side first. Now, here we still have 15F2. Can't do anything about, but these are just two numbers, so we can add together. 5 and 5 give us 10, carry a 1. That'll give us carry the 1. That'll give us 15 F2 is equal to 2200. So if we do 2200 here, 12,220 divided by 15, that'll give us force 2 of 81.3 pounds that's being pushed up. But we also know already that our total weight being pushed up, if our total weight being pushed up is 187, and we already know that one of these, because we already know what F2 is, right? We figured out F2 is 81.3. we can figure out what F1 is. If we want to get F1 by itself, again, we have a plus here, so we have to subtract it. Okay. Well, let's see here. We have 6.7, 106.7. So the first person is carrying 106.7 pounds. The second one is carrying 81.3. So those two forces have to equal, which they do, your force going down and the twisting that this board's experiencing because of this force have to equal out to give you that. Again, now you could do it by saying, well, if I have a 0 here, how does this affect this, and then that going up? It does the same way. In other words, it's distance times force in your clockwise direction has to equal your distance plus your force, and then distance and force in the counterclockwise. So your clockwise and your counterclockwise torque have to equal out because you have a static or non-moving item going on here. Hope this helps out. Let me know if you need any other help. Good luck.